Okay, so copper electrodes were cut, and because the metal was actually quite thick, used the guillotine over in tech studies. They were cut fairly accurately, within at least 0.5 of a millimeter, 20 mil wide by 100 mil long, and the metal is approximately half a millimeter thick. Steel wool was used to thoroughly clean the surface. You can actually see a before and after, and they were irrigated with distilled water to remove any sort of particles of iron, and a light scratch mark was placed at 5 centimeters, so when the electrode was actually submerged, so that would be a consistent depth. The power supply was a brand new one, and it has a lot of features, and which the most important one is digital tracking. Wires were also used to connect to the electrodes, and to fix them we used the alligator clips. Other items was a stopwatch, steel wool for cleaning the surface, digital scales, paper towel, distilled water, a hairdryer and a fan just to help the drying of the electrodes, retort stand for hanging everything up, and of course the usual protective clothing, apron and safety glasses, and gloves if they required it, though the chemicals were fairly low hazard. These are the solutions that we used, so from 0.1 to 1 molar, prepared by our lab technician. And this is the setup, so positive, and the yellows representing the negative power supplied, and they were submerged in the beaker to the depth of the 5 centimeters, making sure the meniscus was there. Voltage was set exactly to 4 volts in this case, and then it was allowed to run. So after cleaning the electrodes, the masses were recorded. Electrodes were then connected to the power supply, and the 4 volts, as you saw in the image, they were submerged to a depth of 5 centimeters. Electrodes were separated by a distance of 7 centimeters, and that was held constant throughout all the testing. Power was then supplied, and it was allowed to run for 5 minutes. Electrical current was recorded over the 5 minutes. At the end of the 5 minutes, they were carefully removed, irrigated using distilled water, and we set up a retort stand with some alligator clips as a temporary clothes dryer. After they had dried thoroughly, that they were re-weighed, and then to measure the change in mass. And of course, this process was then repeated for each of the solutions at different concentrations. To speed up the process, the other set of electrodes, as you saw in the previous image, while the one set of electrodes were drying, then the students were actually reacting with the other set of electrodes just to speed up the time. During the experiment, the electrodes were always handled by the edges, leaving chemicals off the skin, and oils will actually block the surface and decrease the amount of surface area. And as a further measure, this whole experiment was repeated twice using a fresh batch of solutions. Observations: at the lower concentrations, there was some bubbles noticed, but however they were very few and very small. During the initial deconstruction, the students actually had the voltage on 6 volts, and the deposit formed too quickly, and when they actually removed you can see here the bits of copper metal actually fell off the electrodes. So to change that, the voltage was decreased and the time reduced in order to make sure that the deposit formed more coherently. And of course, the students were very careful handling the electrodes because they didn't want to repeat their mistakes again. Current was observed to slightly change over the 5-minute run, and it sort of varied by about 10 milliamps, not too much. And this is their results. You might want to pause the video here. And I'd like to thank my students for coming in during the holidays and working for about 4 hours and sharing with the rest of you. All right, thank you.